These are solutions to 2025's GCSE Further Mathematics Unit 1, which is pure mathematics. The first thing to do is read the front of the paper, and it says first of all, the answers are given at 2 decimal places unless stated otherwise. Okay, and there's a total mark is 100 marks, so every mark is worth 1%. You're given a few formulas, as you can see, and let's get cracking. Okay, first thing we've got to do then is we've got to find x plus 2y, where these are matrices. So if we look at this, the first thing you want to do is write this down, and I'm just writing down the x, which is minus 2, and then 7, and then 4, and minus 3, and then plus, and I've just doubled all of the digits in my y as I've doubled all the digits in my y, so it becomes 4, minus 10, minus 2, and 6. And then when we add those, we're just adding the corresponding elements. So the first row, first column, minus 2 plus 4 is just 2. First row, second column, 7 plus minus 10 is minus 3. And then 4 plus minus 2 is just 2. And minus 3 plus 6 will be 3. And there we are. And we should write it in here. I'm going to speed through and not do that. Next thing for us to do is do our x times our y. And order matters. So x times y is minus 2, 7, 4, and minus 3. My y was a 2 by 3, so it was minus 2, 3, minus 2, 5, minus 1, and 4. And just so we know, that's a 2 by 2, that's a 2 by 3, so they're compatible first of all, because those two inside numbers are the same, and my result will be the two outside numbers, so the result will be yet another 2 by 3. I'm just going to do it here, and we've sort of run out of space, just so we can see it where it is. Okay, now this first element here, its position is the first row, first column. So you do your first row times your first column. So you do minus 2 times minus 2 plus 7 times the 5. And when you do that, you will get 39. Same idea for this one here, which is my first row, second column. So you do first row times your second column. So minus 2 times 3 plus 7 times minus 1, which will be minus 13. And then same idea for this one. It's the first row, third column. So minus 2 times minus 2 plus 7 times 4. And that's going to be 32. And then this one is the second row, first column. So 4 times minus 2 plus minus 3 times plus 5, which will be minus 23. Same idea. I'll just whiz through this here. That's what you'll have. Okay, next one. Complete the graph of tan x from minus 90 to 270. A little bit unusual, but what you should know, they've given you the first asymptote, which is at minus 90. The next one will be 180 degrees later at plus 90, and then 100 degrees later again, which will be at 270. And the graph just goes like this. And folks, you need to be able to label your graph as quickly as I have done. Don't need to go on beyond. I've gone beyond what I needed to do. You don't need that. You need to be able to do it as quickly as I have done. If you don't, aren't able to do that, you have not learned your notes well enough. That is very important. A sort of standard trig graph. The range is a wee bit difficult, but that is it. Okay. Solve the equation. Tan x is equal to 6. You can use the graph. It's a really awkward way of doing it. Nicer to just do this and just do, first of all, let's just write it down again. Tan x is equal to 6, which means my basic angle, and how you get your basic angle is you do tan to the minus 1 of 6. I had written this down. I've done this earlier, and I've written this down. So I had 80.5377. Don't need to really go as far as that, but I have. And then if we do that out, just mark on your cast diagram. My tan is positive, so it's in here or it's in here. So that's my 80.5377. That's 80.5377. So my first angle is round to here. My next angle is round to here. So my answers are going to be 80.5377 or 260.5377. And then what did they tell us to do? 2 decimal places. 80.54 degrees or 260.54 degrees to 2D piece. Okay, the next part of the question, I'm going to keep this on the screen. It says, hence, solve this thing. So because it says hence, you've got to use what you've done before. I would prefer if they just asked you this, to be honest, and start here, but they don't anymore. They seem to ask it this way. So you know then, what's changed from this question is the x values that you've just found. That now becomes 3 theta plus 45. So let's just put 3 theta plus 45 is equal to those two values that we just got, and use the longer versions of them just to keep the accuracy in your answer. Hopefully they've done that in their mark scheme. They really should have. And then if you bring the 45 across, it just takes away from that 80.5377. It's going to give you 35.5377. And over here, it's going to give you 215.5377. And then divide through by your 3, and you will have 11.85 degrees, given that the 2dp's, and 71.85 degrees to 2dp. So hopefully no mistakes there in my working out. Let's check those. Right, next one, we've got a function, and you've got to use your method of completing the square to do this. To use your method of completing the square, first of all, I'm going to write down my f of x, and the only thing I'm doing here is I'm firing a bracket around the x squared term and the x term, and then I know I have to sort this out. I need to get it, complete the square. So this, what you do is you half the coefficient of the x, so minus 3 divided by 2 is minus 3 over 2, and I would leave it like that. That becomes squared, and plus 5, and you must remember to take that away again, then minus 3 over 2 squared. And you can do that on your calculator. The bracket stays exactly the same, and if you did 5 minus brackets minus 3 over 2 squared, you will get as a mixed number 2 3/4, or 2.75. There we are. Hence, write down the coordinates of the minimum turning point. So this thing then, remember this would have been the same. I'm just copying this from earlier, from above. Okay, so that's what we have just completed the square of this thing. So the minimum is going to be equal to 2 3/4, and that happens, I was going to say at, but we'll say when the bracket equals 0, so when x minus 3 over 2 is equal to 0, i.e. that means when x is equal to 3 over 2. So that gives you, I'll write that, I'll just write it as decimals. I think that's 3 over 2 is 1.5, 2 3/4, pardon me, is 2.75. So that's my minimum point. And you really should know it is going to be a minimum. Minimum because it's, if you think about it, it's a U-shaped graph which is going to have a minimum point. Solve the inequality. Solve these as you would solve anything. You would bring it all to one side. You'll have 2x squared minus 7x minus 30 is less than or equal to 0. And then I will just say put 2x squared minus 7x minus 30 equal to 0. And then my sum then is equal to minus 7. My product is equal to minus 60. And then we will factorize that as 2x squared minus 12x plus 5x minus 30 is equal to 0. 2x then upon x minus 6 plus 5 upon x minus 6 equals 0. And then that is going to be x minus 6 upon 2x plus 5 equals 0, which means x equals 6, or x equals minus 5 over 2. Draw your curve. It's a positive quadratic. It now crosses at those two values, and because it was a less than or equal to, we want below, which is going to be in here. So my answer, I'll write that as a decimal, minus 2.5 is less than or equal to x is less than or equal to 6. And that is that one done. Right, question 5 is an inverse matrix question. You've got your matrix. What you now need to do is then find the inverse. So you do that by finding the determinant. And then what you do is you switch the elements in the leading diagonal and you change the signs of the elements in the other diagonal. Now the determinant, first of all, is the product of the elements in the leading diagonal minus the product of the elements in the other diagonal. So it's just going to be 20 minus 6, which is going to be 20 minus 6, which is just going to be, oh, sorry, that should be minus 20 minus 6, which is going to be, so that was a minus 4. Minus 20 minus 6, which is minus 26. Your inverse then is 1 over your determinant, so that's minus 1 over 26, then times switch the elements in the leading diagonal, so these two switch around, so it's minus 4 on top left, or first row, first column I should say, and my 5 on the second row, second column, and then the other two elements change their sign, so they become minuses. Now you might want to write that a little bit prettier. You might want feel it better, make it easier, and make everything inside to be change the sign of everything inside and change the sign of the other thing outside. I don't think I did that in mine, but if you have, that's probably a nicer way of doing it. I haven't done that in the next bit. I only just spotted that. I should have spotted that, but you could do that. So if you've done it that way, it will work out the same. Okay, right, next part of the question is, hence, using the matrix method, solve the following simultaneous equations. So they've told you how to use it, how to do it. If you do it any other way, you will get 0 marks for it because I've specified a certain method. Okay, first thing you want to do is make this into a matrix equation. So 5, 2, 3, minus 4 upon column vector xy is equal to column vector 4, 18. Now the idea here is this. You've got some matrix A times xy, and that is equal to some value, we're just going to say 4, well, it is equal to 418. What you're going to do is you're going to find the inverse of A, and we've done that in our part 1. You're going to put it in front of your, matrix A. Now that's times your xy. Because I put it in front on the left-hand side, I must put it in front on the right-hand side as well. And then what happens? Inverse of A times A is just I. And then if you multiply anything by the inverse, by the identity I, it's equivalent of multiplying numerically of multiplying by 1, so it just disappears really. So there we have, that's what you're going to get. Now that's what you're going to do, but we're going to actually show all the steps to do this. Okay, so let me just fill that in. So first of all then, what we're going to do is, need a wee bit more space here. First of all, what we're going to do then, we've got our matrix 5, 2, 3, minus 4, and we're going to multiply it by our inverse, which we just worked out in the front, in the first bit, in the first part of this question. So if you're going to multiply it by minus 1 over 26 times minus 4, minus 2, minus 3, 5. So we put that in front on the left-hand side. We must put that in front on the right-hand side as well. And then this whole bit here will just become the identity matrix. And then this right-hand side, I'm just going to leave the minus 1 over 26. And this is a 2 by 2 times a 2 by 1. So the result will also be a 2 by 1. So if you did that out, you will get, and I'm going to skip that out, you're going to get minus 52 and 78. And then if you multiply in by the minus 1 over 26, you will get positive 2 and minus 3. And there we have it. Oh, didn't need this last line. And then that means your x is equal to 2 and your y is equal to minus 3. Okay, next question is a lovely little calculus question, a little differentiation question. It says, gradient function of a curve is given by dy by dx is equal to 6x plus 1 over x cubed. It's not actually a differentiation question, it's an integration question. So what we're going to do is we've got to find the equation of the curve. So you've got your dy by dx. I'm going to write it again in index form. And how you get to dy by dx back to y is you integrate. So we're going to integrate this thing with respect to y, with respect to x, I should say. And raise the power by 1 divided by the new power. That's going to be 6x squared over 2, or 3x squared. This one, raise the power by 1, divide by the new power, that's what we're going to have, and then plus your c. I would just write this again as 3x squared minus 1 over 2x squared, and they're both on the bottom line, plus c. And we're told it goes through the point 1, 5, so let's just fire that in. So y equals 5 when x equals 1, 3 times 1 squared, that's going to be minus a half plus c. So what's that going to be? 5 is equal to 2.5 plus c. 5 minus 2.5 is equal to your c. So your c is equal to 2.5. And then just write your equation again. 3x squared minus 1 over 2x squared plus 2.5. Next one, a bit of algebra. Simplify fully the algebraic expression. Lovely. So here we want to, first of all, sort the bracket out. We'll do a common denominator. And then it's still divided by x plus 6 over, and oh, spotted a wee difference of 2 squares. The x squared minus 9, that's going to be x minus 3 upon x plus 3. Common denominator over here is going to be x minus 3, x plus 3. And then top line on the left, for the left bit, needs to be multiplied by x plus 3. Next bit needs to be multiplied by x minus 3. And then we'll go from here. So I think I would just tidy up my top line. It's going to be x squared plus 3x minus, and I'm doing this bracket here. This double bracket is going to be in a long thing here, so that's what I'm doing at the minute. X times x is x squared. X times minus 3 is minus 3x. X times, the 4 times x is 4x. 4 times minus 3 is minus 12. Still divided by x minus 3, x plus 3. And I'm going to flip this dividing fraction across, just because I want to do this cancelling, get rid of it. And you can see x minus 3 goes, x minus 3 goes, x plus 3 goes, x plus 3 goes. So we're just going to cancel tidy up our top line over here. That's going to be x squared plus 3x minus x squared plus x plus 12. And it's all over x plus 6 now. And if we tidy that up, I would do these steps out, because this is where people go wrong, not doing these steps out. So you can see all I've done in this next line is I've multiplied through everything in that bracket by a minus. And then I can see my x squared and my x squared on top line cancel. 3x minus x is just 2x. And then I have minus 12 all over x plus 6. And an awful lot of people will stop here, keep going, factorize. Oops, that should have been a plus 12. I've messed something up there. Yes, have we look here. That should have been a minus 12 here, and then when you subtract, minus minus becomes a plus. That should be plus 12. And then factorize the top line, and then your bottom line is x plus 6. And then you can see the x plus 6 goes, leaving you just 2. Now, I think if in an exam I got an answer like 2 after all that work, I'd be pretty confident I got it right. That's very nice. That's been well engineered to give us a lovely answer. Okay, next one, we've got, this is a differentiation question now. We've got our y, and we've got to find dy by dx. First of all, write your y in index form as 4 over 7, x to the minus 3. Your dy by dx then is equal to minus 3 times 4 over 7, x to the minus 4. And that's going to be minus 12 over 7, x to the minus 4. Something people are very, very bad at. I would write my x, this is really what's going on in my head. I'm writing my x to the minus 4 as 1 over x to the 4, and then that is the same as multiply along the top, minus 12 is on the top, multiplying along the bottom, 7x to the 4 is on the bottom. So because I've given the original thing with an x on the bottom line, I would really be thinking this may not be enough to get me the full, it's only 1 mark, that's wild for 1 mark, that is very harsh. Hopefully they would give you then the mark then for this, because you've still differentiated successfully. But I would generally, if I write it with an x in the bottom line in the question, I would be wanting the x in the bottom line in the answer as well. Right, hence use your answer to part 1 to solve the equation y is equal to minus 2 dy by dx. So my y from earlier on was 4 over 7x cubed, and my dy by dx we've just worked out to be minus 12 over 7x to the 4. That looks awful. Let's have a wee go and see what we can do here. So let's just tidy up. That's going to be 4 over 7x cubed is equal to positive 24 over 7x to the 4. And then I think I would just do a wee bit of cross multiplying, would I? I would indeed. That's going to be 28x to the 4 is equal to 24 times the 7, which is 168x cubed. And then we will then bring it all across to one side. You'll have 28x to the 4 minus 168x cubed is equal to 0. And 28x cubed comes outside a bracket, leaving me x minus 6, which means x is equal to 0 or x is equal to 6. So x equals 0 or x equals 6. I wonder, is there a reason why we can't have our 0? Yes, there is. You couldn't have a 0. X is not going to be equal to 0 in this, because you put 0 into that. 4 over 7 times 0, you're going to get a maths error. So your answer, I would definitely do what I've just done, but I would say my answer is just x equals 6. Just say impossible. In the context of this question, that's going to be impossible because it's not going to exist. Okay. Right, express this as a single log. So these are using, using your 3 rules of logs. Your rules of logs are log A plus log B is equal to log AB. Your next one is log A minus log B is equal to log of A over B. And your last one is n log A is equal to log A to the power of n. So that's all we've got. So here, first thing I'm going to do is write, that's that's going to be log A minus, and I'm going to just say that's 4 log B to the power of a half plus log C. And that's going to be log A minus that 4 comes up and it becomes log B to the power of a half, and that thing is now to the power of 4. And that's going to be log A minus, and then something to the power of something, that's going to multiply those powers, an index number to the power, that's going to be log of B squared plus log of C. I like to sort to do positive ones, so I've got a log A plus a log B, log C, that's going to be log AC minus log B squared, and then that's going to be log AC over B squared. I think that's as far as we can go, is it? Log AC over B squared it is indeed, yep, lovely. Next one, lovely questions. I love log equations. We've got here, right, we would just take logs, and I'm going to use my calculator once in this, take logs, and you're going to have 3x plus 1 log 5 is equal to 2 minus x times log 7, and then just multiply it out. That's going to be 3x log 5 plus log 5 is equal to 2 log 7 minus x log 7. Bring all the x's to one side. Everything else goes over to the other side. Factorize out the x, so 3 log 5 plus log 7 is equal to 2 log 7 minus log 5. X is equal to 2 log 7 minus log 5. Your expression inside the bracket goes across the other side, so it now divides. and you do that, let me just check my working out. Yes, that's what I've written down here. And then that is 0.33692. And I think it was the 2 decimal places, 0.34 to 2 decimal places. Lovely. Very, very nice indeed. Okay, from one really nice logs question to a horrible one. And this is our log graph question. Okay. Tommy recorded the time, TRs, he spent revising the night before each of his further mathematics tests and the marks M% he achieved. The results are shown in the table below. Tommy believes the relationship is in the form M is equal to K T to the power V, where K and V are constants. Verify the relationship of the form M is equal to K T to the power V exists by drawing a suitable straight line on the grid opposite. Label the axes clearly. Show clearly the values used. Correct the 1 decimal place in the table above. Okay, before I do this, I like to take this thing here, and I think this is why I leave this little bit of space for you always here. I like to take logs of both sides. So I'm going to have log M is equal to log K T V. That's log M is equal to log K, plus log T to the power V. And then that is the same as log M is equal to, and I'm just going to, for this one, bring the V down in front. So it's V log T plus my log K. Okay, why I've done that, that really helps me, because then remember my Y is equal to MX plus C equation. That tells me log M goes on the vertical axis, log T goes on the horizontal axis, and then this V is equivalent to the gradient. So that's how we're going to do. The K, log K is technically, it's a y-intercept, but more often than not, you're not able to find it, so we'll use a different method to do this. Okay, so log T is on the horizontal axis, log M is on the vertical axis. We'll come back to that, as you'll see in a minute. Right, I've got log T and I've got log M, and I'm just copying from the work I've already done. It mentioned earlier on to do that to 3 decimal places. Mentioned down here 3 decimal places, so I'm just going to do those. I've already done these. Please do check yourself that I have done these correctly. This is my least favourite question. They're very time consuming, and you've got to plot a graph, which I hate doing, and I'm not going to do. You have to do it in an exam, but I'm not going to do it. Okay, right. So remember, log M was on the vertical, and this was part of this thing. To draw this, log T was on horizontal. 6 marks, folks, so you've got to draw this accurately. You've got to plot those points, and wherever those points are going to be, very roughly. Let's do this very, very quickly, and this is very, very rough, folks. I had done this earlier at some stage, but these are incredibly rough where they are. Okay, very, very roughly, but you can see they're in a straight line anyway. Right, I'm using it. You can see roughly they're in a straight line. You would use your ruler to show they're in a straight line, folks, but there you go. Okay, now what you're going to do is you're going to pretend you're using the first point and the last point. So let me get rid of that I can actually see them. So on your diagram, I would draw that wee right angle triangle, because you're going to pretend you're using that from your graph, okay? But you're really using the first point and the last point. You can use any points you could do, but if you could use like those two, which are quite close together or whatever, but you're better, it gives you more accuracy if you use points which are further away. So that's what we're going to do. So we're really going to use this point here, my first point, and my last point to find my gradient, which was V, my gradient V. So my gradient V, to work this out then, and we're asked to do this in the next part of the question, hence find the values of k and v, correct the 2 decimal places. So we're going to say our gradient v is equal to our log m difference over my log t difference. And again, I'm hoping I've done this correct. That was 1.806 minus 1.944 over 0.076 minus 0.439. And that works out as 23 over 60. Okay, that's a perfect answer. Leave it as that. We'll get the value to 2dp's in a wee minute. Once you've got your value of v, sub into, and my method of this has changed over the years, but I'm going to sub into the original equation. So that's m is equal to k t, and now t is the power of 23 over 60. And then we're going to put in one of the values. So I'm going to scoot back, and I'm going to put in this original pair of values. So when t is equal to 2.75, my m is equal to 88. I'm going to put those in. So sub in, what was that? M is equal to 88, t is equal to 2.75. So that means 88 is equal to k times 2.75 to the power of 23 over 60. That means 88 divided by 2.75 to the power of 23 over 60 is equal to k. So k is equal to 59.7134, and that means k is equal to 59.71 to 2 decimal places. I would also write down my v now to 2 decimal places. V was 0.38 to 2 decimal places, and then fire those in to this answer line. Okay, lovely. Now they've asked you to find those. I think going forwards we're going to use those values for the rest of it. Okay, it says show clearly using the values of k and v that in the relationship m k t to the power of v does not hold if Tommy revises for 4 hours. I have no idea. Right, first of all, let's write down our equation. M is equal to 59.71 times t to the power of 0.38. So if Tommy revises for 4 hours, let's just fire it in and see what happens. M is equal to 59.71 4 to the power of 0.38. And then he gets, he gets 101.12 to 2 decimal places. And just say, and of course that was his percentage, which is over 100%. Which is not possible. Okay, and that's it. Lovely. Okay, right, good. Get rid of that one. Right, it says curve is defined by the equation y is equal to 4x squared plus 4x minus 1. Find the coordinates of the points where the curve meets the x-axis. Meet the x-axis, you put y equals 0. So 0 equals 4x squared plus 3x minus 1. I will just do my sum and product, and to do that, and so my sum is equal to 3, my product is equal to minus 4, my two numbers are 4 and minus 1, so 0 is equal to 4x squared plus 4x minus x minus 1, so that's going to be 4x times x plus 1 minus 1 times x plus 1, so that's going to be 0 is equal to x plus 1, 4x minus 1, which means x is equal to minus 1 or x is equal to a quarter. So my answers, minus 1, 0 is one of my points, and a quarter, 0 is one of my other points. Write down the coordinates where it meets the y-axis. To meet the y-axis, you put x equal to 0, and then it's going to be 0 plus 0 minus 1, so y equals minus 1, and my answer then is 0 minus 1. Okay, using calculus, find the coordinates of the turning points of the curve. Right, let's write down my y again. Y was 4x squared plus 3x minus 1. And we're going to do, to find the turning point, you find your dy by dx, which is 8x plus 3. and then you put it equal to 0. So put dy by x equal to 0. So 0 equals 8x plus 3. Minus 3 is equal to 8x. X is equal to minus 3 over 8. That's a perfect value for my x. And then I would just say when x is equal to minus 3 over 8, y is equal to 4 times minus 3 over 8. It gets squared. Plus 3 times minus 3 over 8. Just subbing. So all I'm doing here, sorry, is subbing that back into the y. My y works out to be minus 1 and 9 over 16th is what I worked out. So my turning point is minus 3 over 8, minus 1 and 9 over 16. I would leave it as that, to be honest. Yep. Okay, right, next bit says, show clearly why this turning point is a minimum. So, your dy by dx was 8x plus 3. If you differentiate that again, you get 8, which is greater than 0. And that tells you, therefore, your point, minus 3 over 8, minus 1 and 9 over 16th is a minimum turning point. Okay, hence using answers to parts 1 to 4 sketch the curve. So what did we know? We knew it crossed at minus 1 on my x-axis, and also a quarter, was it? Yeah, it was a quarter. And it also crossed the y-axis at minus 1, and then it had a minimum turning point, which we've just done then. So the minimum turning point is minus 3 over 8, and then minus 1 and 9 over 16. Okay, and the next one almost there. Well, we're not almost there at all, we're miles off. Right, find the area enclosed by the curve and the x-axis and the lines x equals minus 1, minus a half, and 0. So your curve was like that. Remember, it crossed at minus 1 and a quarter. We want to find minus a half and 0. So we want to find this wee area in here. So your area is equal to the integral between minus a half and 0 of 4x squared plus 3x minus 1. When I integrated that, what on earth did I get? I got a square bracket first of all. I got 4x cubed over 3 plus 3x squared over 2 minus x. That's between 0 and minus a half. And then put the 0 in. 0 into all of those values, you get 0. And then put the minus a half in. And if I did that, I got 0 minus 17 over 24. Again, you check that, please. And that gives me minus 17 over 24. Why on earth does it give me a negative? It gives me a negative because my area is beneath the x-axis. But just say, therefore, area is equal to 17 over 24 units squared. Okay, and I probably should have given that the 2 decimal places. I haven't done. Anyway, right. Right, simultaneous equations. On these, by the way, folks, exam technique, they're very nice to us nowadays. They give you they give you the equations that you're trying to find. You can see they've given you these equations. That's the first part of it. And then later on, they ask you to solve these equations. And that's worth 8 marks. Quite often people can't get these bits. But if you don't get these bits, you can still get the 8 marks because you can still actually solve the simultaneous equations. So you might lose those bits, and you may also lose this next bit because you might not understand it if you don't understand the first few bits. But you can still get 8 marks for solving. So don't write yourself out of those marks just because you can't do the first bit. Okay, right. What do we got? Andy, Bella and Conrad have been on a trip together to Germany, Poland and Sweden. They need to convert their remaining foreign currency into pounds after coming home. Table below shows how much each foreign currency they returned with. So, for example, Andy returned with 1,200 euros, 700 whatever these are, and 600 krona on the 16th of April. And X, Y, and Z represent the different things and convert them respectively. The 16th of April, and he converted his foreign currency and received £1,200 on the 16th of April. So he has got, we're going to say that he's got 1200x, 700y, 600z, and he gets, he received £1,200. So that's, we're going to write down, we're going to just write down first of all 1200x plus 700y plus 600z is equal to 1200, and then clearly you would just divide through by 100 to give you 12x plus 7y plus 6z is equal to 12, and that's going to be my first equation. Okay, so that's how they've got that. You didn't need to do that. That was just me showing you what they're up to. They were very nice by doing that. Part 1 then, you're looking at Bella. Bella converted her foreign currency and received £800. So this is Bella. So Bella is 300x, 2700y, 800z, and she's going to get 800. So let's just write that in. That was 300x plus 2700y plus 800z, and that was 800. Nice and easy again. Divide through by 100, you're going to get just 3x plus 27y plus 8z is equal to 8. That will be my equation 2. Conrad, but things changed for Conrad. Conrad converted his foreign currency a month later when the rate in pounds and for each, whatever they are, has decreased by 40%, and the rate for the krona had increased by 20%, and he receives this. So dollars must have been the same. Was it dollars? Did I mention dollars? I have no idea. Or no, it was euros, sorry, in Germany. So 800 euros. Sorry, what was he? Sorry, Conrad was, yes, 800 euros, 800, 2,500, and 500. So 800 is going to, euros is going to be the same. This middle one then has decreased by 40%. So it's 0.6 times 2,500 that he had, y, and the other one had increased by 20%, so 1.2 times 500 times the z, and that is going to give him £1,000. So let's just sort that out. That's 800x plus 1,500y plus 600z is equal to 1,000. And clearly here, you could divide by 100 again. So you're going to get 8x plus 15y plus 6z is equal to 10. And that's my third equation. Now, a lot of people are not going to get that. They're not going to know this line here, understand what's going on. If you don't get it, folks, they've given you the equation. You can still go on and get the most of the marks. Okay. Next thing we've got to do is solve this. Now, an awful lot of people didn't like this because the answers didn't work out as nice, pretty numbers. That happens sometimes. They weren't too bad. They were decimals, but they weren't too bad. Okay, right. Find the values of x, y, and z. Show clearly each stage of your solutions. Now, folks, they know rightly that a lot of calculators can do these, give the final answers, but they don't show the working out. So you've got to be able to do this. Got to be able to do this method and find all of these things. Now, I'm going to show loads of working out here. First thing I'm going to say is elim z, so eliminate z. And I'm going to do that first of all. You can see in my equation 1 and equation 2, equation 1 and equation 3, I have 6 z's in each of them. So what I'm going to do, I'm going to do equation 1 minus equation 3. Notice I wrote that down first. And then do equation 1 minus equation 3. You'll get 4x and minus 8y is equal to 2. And that will be my new improved equation 4. I'm also going to have to eliminate, I'm going to use 1 and 2. So I'm going to have to get the same number of z's in both. So I'm going to do 4 times my equation 1, because that will give me 24 z's. And I'll do 3 times my equation 2. That'll also give me 24z. And what that gives me is 48x plus 28y plus 24z is equal to 48. and then 9x plus 81y plus 24z is equal to 24. And then if we subtract, subtract. So really what I'm doing here is 4 times my equation 1 minus 3 times my equation 2. And I will get 39x minus 53y is equal to 24. And this will be my equation 5. So let's have a look at my equation 4 and my equation 5. They are both in terms of x and y. And this is what people really didn't like. They're not nice at all. I'm going to say eliminate my x. And I want to get the same number of x's in both equations. So I turn the brain off and just think I'm going to multiply my fourth equation by 39. And I'm going to multiply my fifth equation by 4. So that will become 156x minus 312y is equal to 78. And 156x minus, and I'm going to just check that because I can't read my own handwriting. This is not good. That's minus 212y is equal to 96. We've now got the same number of x's. I'm just going to write down this time subtract. And if I subtract it, I will get minus, that's going to be, I've got minus 312 minus, and then minus 212, that is going to be minus 100. Minus 100y is equal to minus 18, which means my y is equal to minus 18 divided by minus 100. And that means my y is equal to, and that's going to be 9 over 50. 9 over 50, and I'll leave it as a fraction. Once I've got my 9 over 50, I will sub into 4. Fire that back into my equation 4. Where is my equation 4? You can just about see it on the screen there, that top yellow thing there. So that's me 4 times x, 4 times x minus 8 times 9 over 50 is equal to 2. A little bit of working out, my 4x is equal to 86 over 25. My x then works out to be 43 over 50. Sub those both into equation 1 and put it into the original equation 1. So that's 12 times 43 over 50 plus 7 times 9 over 50 plus 6z is equal to 12. Good bit of working out, bringing that all across. You'll have 6z is equal to 21 over 50, which means your z is equal to 7 over 100. Okay, and then you can put those in. Your x then is, what is that? Sorry, that's going to be 43 over 50. I'd write that as a decimal, I think I would do. My x is equal to 0.86. My y is equal to, my y as a decimal then is 0.18, and my z as a decimal is 0.07. Okay, last part of the question. On the same day that Conrad converted his foreign currency, Dylan converted 115 into these Polish things, and then how much did Dylan receive? So, this is what we've got. And it was decreased. What happened to it? It was decreased by 40%. Yep. So he just has to do, you just really need your y. Where on earth have I gone here? You just need your y. So he ate £150. It's decreased by 40%. So it's 0.6 times 0.18. And let me just do that out in my calculator just to check. 150 times 0.6 times 0.18, and that works out to be, and I got 16.2, and there we go. Lovely. Okay, right. Next one. Curve is defined by the equation y is equal to 3x squared minus 5x minus 1. Gradient of the tangent to the curve at the point P is equal to 5. Find the equational tangent to the curve at the point P. Okay. Right, mentions tangent. If it mentions tangent, normal, parallel to, perpendicular to, all of these things, you're thinking dy by dx. So dy by dx, differentiate your y, you get 6x minus 5. And then we're told the gradient is equal to 5. So put 5 equal to 6x minus 5, which means 10 is equal to 6x, which means 10 divided by 6 is equal to x, which means my x is equal to 5 over 3. I would then find my corresponding y value. So just say when x is equal to 5 over 3, y is equal to 3 times 5 over 3 squared minus 5 times 5 over 3 minus 1. Let me just check that. Yep. So y is equal to minus 1. Very good. So my point then is 1 2/3 minus 1. That's a point my tangent goes through. Okay, so then to find the tangent, it's y equals 5x plus c, because we're told that tangent's a straight line and we're told it has a gradient of 5. Now we're going to just fire in that point, which is 1 2/3 minus 1. So let's just fire it in. So my y value is minus 1. 5 times 1 2/3 plus your c. So that's minus 1 is equal to 25 over 3 plus c. And then a wee bit of working out, that works out to be minus 28 over 3. Yep, that would be right, yep. And that means my y is equal to 5x minus 28 over 3. Or I suppose we could write that as y is equal to 5x minus 9 1/3. Okay, next one says point Q also lies on the curve. The tangent to P is perpendicular to the tangent to Q. Okay, so that means the gradient at Q is it's perpendicular to P. P had a gradient of 5, so Q has a negative reciprocal of that, so Q is equal to, gradient of Q is minus, tangent of Q is minus 1/5. So we're just going to put minus 1/5 is equal to our dy by dx. So that means minus 1 over 5 is equal to 6x minus 5. That means, bring that minus 5 across, 5 minus 1/5 is going to be 4 4/5 is equal to 6x. And a little bit of working out, x is equal to, it's going to be, oh, let me just check that. I think I've made a mistake there, have I? 4 4/5 divided by 6. Oh, no, x is equal to 4/5. And then again, you're putting that back into the y. So just when x is equal to 4 over 5, y is equal to 3 times 4 over 5 squared minus 5 times 4 over 5 minus 1. Y is equal to minus 77 over 25. And my answer is 4 over 5 minus 3 2/25. Okay, and we've made it to the last question, thankfully. So it says a poster designer is making a sign for a client in the shape of an isosceles triangle on top of a rectangle. The dimension with a design with dimensions in meters is shown in the diagram below. The area of the triangle ABCD is the rectangle ABDE is 12 meters squared, so that's 12 meters squared. And we've got to show that y is equal to 2 over x. No idea. Okay, right. Well, the area is equal to 12, and your rectangle, the dimension, oh, there we are. The dimensions of the rectangle are just 6x times y. So that means a wee bit of working out, y equals 12 over 6x, which means y is equal to, and that's just going to be 2 over x. Lovely, that's not too bad. The length of BC is 5x. Show that the expression for the perimeter of the sign can be written as this thing. Okay, right. BC is 5x. So that's 5x. Okay, right. I will have do a wee diagram then. So right, if we just zoom in on this, you can see the height of that wee triangle is 4x, and the diagonal is 5x, and the base of it is 6x. So this wee bit here is also going to be 3x, and we're going to zoom in. We're going to look at this wee right angled triangle. and we're going to go from here. Okay, so if that's 5x, I don't think we even need that, do we? No, we don't. We're looking for the perimeter. We don't even need to do that. So we're looking for the perimeter. So if that's 5x, that will also be 5x. That's another y. Yep, so your perimeter is just going to be, I'll write this in again properly in the other bit. It's going to be 5x plus a y plus a 6x plus another y. So your perimeter is going to be, what's that going to be? 16x plus 2y. And then we'll put that in terms of everything else. So your perimeter really is just equal to, so the perimeter is equal to 5x, what did I just say? 5x plus y plus 6x plus y. So my perimeter is, that's going to be 16x plus 2y. So that's going to be 16x. My y, remember, was 2 over x. So multiply that by 2, you're going to get 4 over x. Oh, and there we are, we've got it. Again, folks, exam technique, if you weren't able to get that, as a lot of people won't, you can still get all the marks for the next part of the question because they've told you the perimeter, so they're being very nice to us here. Okay, hence using calculus, find the value of x, it will give a minimum possible perimeter of the sign, showing that it is minimum. Let's write our perimeter in index form, and then we're going to differentiate it. So do dp by dx, you're going to get 16 minus 4x to the minus 2, and then I would just write that again as 16 minus 4 over x squared. I think it's nicer to work with. To find a minimum, put that equal to 0. So 16 minus 4 over x squared. That means 4 over x squared is equal to 16. That means 4 equals 16x squared. That means a quarter is equal to x squared. That means x is equal to plus or minus a half. Okay, so we've got our x is equal to plus or minus a half. So because it is length, obviously, we're dealing with here, we're going to have to say that our length is equal to plus a half. Bear with me, sorry, this pen has just died on me. I.e., that means my x is equal to a half. And what does the question say? Hence, using calculus, find the value of x that will give a minimum possible perimeter of the sign. So you've got to now do d2p by dx squared. And if you differentiated this thing again, you would get plus 2 times minus 4, which is going to be 8, times x to minus 3. And then you must say when x equals a half, our d2p by dx squared is equal to 8 times a half all to minus 3. And that thing overall works out to be positive. Therefore, that means it's a minimum perimeter. And that is it. I think that is us done. It is indeed. Happy days. Nice enough wee paper. Very good.